Overview. Why are we studying this subject? To develop a good perspective to understand the unconventional machining processes, to understand the machining of complex shapes and high-strength materials to very high order of accuracy and tolerance, needs advanced machining techniques using energies in unconventional ways, to learn about the various process parameters and their influence on performance and their applications, to understand its relative advantages over conventional techniques. How is it linked with other subjects or branches of engineering if applicable? Unconventional machining processes describes knowledge-based system developed for identifying the most appropriate non-traditional machining process to suit specific circumstances. Advancement of technology in unconventional machining process are used in the field of space research, missile and nuclear industry. Different concepts we are going to learn in this subject and how they are interlinked or interrelated. Need for non-traditional machining methods comprises classification, process selection and application of modern machining processes. Ultrasonic machining deals with basic elements, parameter, applications and limitations of the process. Abrasive jet machining, water jet machining, and abrasive water jet machining provides the principles, applications, and limitations of the machines. Electrochemical machining elaborates chemical and electrochemical machining processes. It includes some hybrid machining processes, namely electrochemical grinding, electric discharge grinding, and similar others. Thermal metal removal processes deals with principle and application of electric discharge machining, electric discharge grinding, and via EDM. Electric beam machining and laser beam machining deals with the principle, theory, and application of the machine. Plasma arc machining deals with the process parameters and other applications of plasma in manufacturing industries. Magnetic abrasive finishing, abrasive flow finishing, electro-stream drilling, shaped tube electrolytic machining deals with the principles and applications of the machines. What are the applications? And where do we use the concepts studied in the subject? Unconventional machining process finds a lot of application in aerospace and precision industries. Advanced materials, more complex shapes, low rigidity structures, and micro-machined components with tight tolerances and fine surface finish are manufactured. Rapid technological development in the field of new materials and alloys with ever-increasing strength, hardness, toughness, heat resistance, and wear resistance. Machining processes. Learning objectives. At the end of this topic, you will be able to describe the needs for non-traditional machining processes, classify the methods of modern machining processes, explain the considerations in process selection, list the applications of unconventional machining processes. Outcomes. By the end of this topic, you will be able to understand the needs for non-traditional machining processes, discuss the methods of modern machining processes, understand the considerations in process selection, discuss the applications of unconventional machining processes. Firstly, let us see the needs for non-traditional machining processes. Technologically advanced industries like aeronautics, nuclear reactors, automobiles, etc. have been demanding materials like high-strength, temperature-resistant alloys having high strength-to-weight ratio. During conventional machining processes, an increase in hardness of work material results in a decrease in economic cutting speed. This also needs the development of improved cutting tool materials so that the productivity is not hampered. Production of complex shapes in materials like titanium, stainless steel, mnemonics fiber-reinforced composites, satellites, cobalt-based alloys, ceramics, and by traditional methods is still more difficult. Making of intricate and accurate shapes are commonly required in the products used in industries like aerospace, nuclear reactors, missiles, turbines, automobiles, etc. By comparing the traditional and non-traditional approaches, we can be able to know the differences. Mechanical energy is used as a primary source in traditional machining methods. In advanced machining methods, electrical, chemical, optical energy sources are used. Primary method of material removal in traditional methods is shearing. Non-traditional methods do not use shearing. They use erosion. A basic abrasion process like polishing, buffing, lapping, grinding, honing, superfinishing come under traditional machining process. Advanced process like abrasive jet machining, ultrasonic machining, water jet machining, magnetic abrasive finishing come under non-traditional machining process. Generally macroscopic chip formation by shear deformation. Example, turning, milling, etc. Generally, microscopic chip formation by electrochemical dissolution. Example, spark erosion, electrochemical erosion, etc. Non-traditional machining process, NTM process. Material removal may occur with chip formation, or even no chip formation may take place. For example, in abrasive jet machining, chips are of microscopic size, and in case of electrochemical machining, material removal occurs due to electrochemical dissolution at atomic level. In NTM, there may not be a physical tool present. For example, in laser jet machining, machining is carried out by laser beam. However, in electrochemical machining, there is a physical tool that is very much required for machining. In NTM, the tool need not be harder than the workpiece material. For example, in electrodischarge machining, copper is used as the tool material to machine hardened steels. Mostly, NTM processes do not necessarily use mechanical energy to provide material removal. They use different energy domains to provide machining. For example, in water jet machining, mechanical energy is used to machine material, whereas in ECM, electrochemical dissolution constitutes material removal. Why do we go for these advanced machining processes? The growing industrial requirements in machining processes are better finish, low values of tolerances, higher production rates, complex shapes, automated data transmission, miniaturization, etc. The machine tools should be easily adaptable for automation as well. To meet such demands, a different class of machining processes, that is, non-traditional machining processes, or more correctly named as advanced machining processes, have been developed. These newer methods are also called unconventional in the sense that conventional tools are not employed for metal cutting. Here, you can see the classification of advanced machining processes. The advanced machining processes can be classified into three basic categories, that is, mechanical, thermoelectric, and electrochemical and chemical machining processes. There are different kinds of mechanical methods being used in industries. In abrasive jet machining process, kinetic energy of either abrasive materials is utilized to remove material from the workpiece. In ultrasonic machining process, the material is removed by the abrasive grains, which are driven into the work surface by a tool oscillating normal to the work surface. In water jet machining, kinetic energy of water jet is utilized to remove material from the workpiece. Abrasive water jet machining also uses kinetic energy of abrasive materials flowing along with water jet. The abrasive flow machining, also known as abrasive flow deburring, is an interior surface finishing process characterized by flowing an abrasive-laden fluid through a workpiece. Magnetic abrasive finishing is also a finishing process in which magnetic abrasive brush is utilized to reduce surface irregularities from the pre-machined surfaces. Application of mechanical methods. HAM is used for abrading and frosting glass more economically as compared to etching or grinding. It is a good method for deburring small hole, like in hypodermic needles, and for small mill slots in hard metallic components. Ultrasonic machining is used primarily for cutting hard, brittle materials that may be conductors of electricity or insulators. Other common applications of USM include cutting semiconductor materials, such as germanium, engraving, drilling fine holes in glass, and machining ceramics and precious stones. HAM can be used for drilling, cutting, deburring, cleaning, and etching. Now, we are going to see the different types of thermoelectric methods. Plasma arc machining is a method of metal cutting with a torch which produces a high-velocity jet of high-temperature ionized gas, plasma, that cuts the workpiece. Laser beam machining is a method of cutting materials by melting and vaporizing it with an intense beam of light from a laser. The electron beam machining technique. A beam of high-velocity electrons is focused on a workpiece where the kinetic energy of the electrons are converted into heat, which vaporizes the material. Electric discharge machining is a process which is capable of machining hard and tough but electrically conductive materials economically and accurately. In ion beam machining technique, a stream of charged ions of an inert gas, such as argon, is accelerated and directed towards a solid workpiece, which removes atoms from surface of the object. Application of thermoelectric methods. The PAM process is used for the profile cutting of flat plate, grooves in stainless steel, and for turning large hardened steel rolls. EBM is used as an alternative to light optics manufacturing methods in the semiconductor industry. Welding can also be done with an electron beam, notably in the manufacture of aircraft engine parts. LBM is used to drill and cut ceramics and substrates. For integrated circuits, the aircraft industry uses CNC-controlled lasers to cut profiles and to drill holes in engine parts. The types of electrochemical and chemical methods are electrochemical machining, a controlled anodic dissolution process that yields high material removal rate, which is independent of any physical and mechanical properties of work material. But work material should be electrically conductive. Chemical machining is an etching process which has very narrow range of applications, mainly because of very low MRR and difficulty in finding a suitable etchant for the given work material. Difficulty in finding application of electrochemical and chemical methods. ECM can be used to make disc for turbine rotor blades made up of HSTR alloys. ECM can be used for slotting very thin-walled collets. ECM can be used for copying of internal and external surfaces, cutting of curvilinear slots, machining of intricate patterns, production of long curved profiles, machining of gears and chain sprockets, production of integrally bladed nozzle for use in diesel locomotives, production of satellite rings and connecting rods, machining of thin, large diameter diaphragms. ECM principle has to be employed for performing a number of machining operations, namely turning, planing, broaching, grinding, fine hole drilling, die sinking, piercing, deburring, plunge cutting, etc. ECM can also be used to generate internal profile of internal cams. Now we are going to see the considerations in a process selection. To make efficient use of modern machining processes, it is necessary to know the exact nature of the machining problem. It is to be understood that 1. These methods cannot replace the conventional machining processes. 2. A particular machining method, found suitable under the given conditions, may not be equally efficient under other conditions. A careful selection of the process for a given machining problem is therefore essential. Before selecting the process to be employed, the following aspects must be studied. 1. Physical parameters. 2. Properties of the work material and the shape to be machined. 3. Process capability. 4. Economic considerations. Summary. By the end of this topic, let's summarize. In traditional machining process, mechanical energy is used as a primary source. It is also called as conventional machining process. In non-traditional machining process, electrical, chemical, optical energy sources are used. It is also called as unconventional machining process. In NTM, the tool need not be harder than the workpiece material. For example, in electrode discharge machining, copper is used as the tool material to machine hardened steels. Performance of NTM processes depends upon hardness, strength, and other physical and mechanical properties of the work material.